Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss the important functional blocks in 8255, that is the programmable peripheral interface. So, based on my previous YouTube video, you may know what is the use of 8255 and what are the pins available in 8255 and what are the blocks in 8255. So as per my previous YouTube video, this 8255 will consist of 4 important blocks and it also a 40 pin IC. The 4 important blocks are data bus buffer, read write control logic, group A and group B controls, port A, port B and port C. Now we will see individually in the explained manner. Data bus buffer. This is a tri-state bidirectional data bus buffer used to interface the 8255 to system data bus. Data is transmitted or received by the buffer on execution of input or output instruction by the CPU. Read-write control logic. This unit accepts control signals, that is RD, WR means read and write, and also inputs from address bus and issues commands to individual group of control blocks through group A and group B. It has the following pins. One is the chip select bar, RD bar, WR bar, RESET, that is reset, A1, A0. Group A and Group B controls. These blocks receives control from the CPU and issues commands to the respective ports. That is, Group A means port A fully and higher bits of port C. Group B means port B fully and the lower bits of port C. Port A, this has an 8-bit latched or buffered output and 8-bit input latch. It can be programmed in 3 modes. One is the mode 0, mode 1 and mode 2. The next one is the port B. It can be programmed in mode 0 and mode 1. Next is the port C. It can be programmed in mode 0 mode. So this is the control word register. Depend on this figure, each data will do the specific operations. Then the modes of operation of 8255. First one is the BSR, that is bit set reset mode. It will set or reset the bits in port C. So depend upon the port C, either they have been used for upper port or the lower port. Next, input output mode. Whenever it mode 0, it will do the simple input output operation. Whenever it is mode 1, it will do the handshake mode of operation. Whenever mode 2 is selected, it will do the bidirectional data transfer work. Next, BSR mode, that is bit chip select reset mode. So based on this, 7 bits depend upon, it will do the process of always 0 for BSR mode, don't care mode, port C bit chip selected mode and set reset mode. So depend upon the selection of B3, B2, B1, we can choose the port C for a particular kind of output operation. Next, input output mode. Input output modes are 2 types. One is mode 0, mode 1. Mode 0 means simple input and output mode. Port A and port B are used as simple input output ports. Port C has 2 4-bit ports, that is, port C is divided into either a low port or a high port. Features of this input output mode are outputs are latched, inputs are not latched, that is, it can do only the output delivery, not by taking the inputs. Ports do not have handshake or interrupt capability. So this is the mode 0 mode, that is, all are do the output mode, that it doesn't connect any input for their operation. Next, mode 1, input or output with the handshake mode. Handshake signals are exchanged between microprocessor unit and peripheral unit. Features of this mode 1 are port A and port B are used as a simple input output ports. Each port uses 3 lines from port C as a handshake signal. Input and output data are latched. Interrupt logic is supported. Mode 2, bidirectional data bus buffer. It is used primarily in applications such as data transfer between 2 computers. Features of this mode 2 are port A can be configured as the bidirectional port, port B in mode 0 or mode 1, OTA uses 5 signals from port C as a handshake signals for data transfer. Remaining 3 signals from port C used as simple input output or handshake for port B. So thank you for watching my video. In this YouTube video, I discussed the detailed explanation of what is the use of individual blocks in 8255. That is, what is the use of data bus buffer. Mainly the data bus buffer is used for controlling the data between programmable peripheral interface with the microprocessor. Then read-write control logic. Depend upon the read bar or write bar, the microprocessor will choose the read operation or write operation. Then what is the use of group A and group B control. So next YouTube video I am going to discuss the keyboard and data display controller. Thank you for watching my video.